Hello and welcome back. In this video I'm going to discuss more of the tools that we can use in the C programming language to do some of the things we're accustomed to doing in C++. So in C++ we use classes to create custom data types that we can use when doing object-oriented programming. The C programming language doesn't support classes, but it does have something called a struct, and a struct does basically half of the idea of a class. A class allows us to group data and functions or instructions together that are in some way related to each other. In C, we can use structs to group together data that are related to each other, okay, but not the methods. So structs in C cannot contain methods. Now, this can be confusing because in C++ you can also create something called a struct, and it can have methods. In reality, there's not that much difference between a struct and a class in C++, with the principal difference being that by default everything in a struct is public and everything in a class is private unless we specify otherwise. In C, however, there is not a notion of public and private. So we just create a struct and we can put data in it and we can access that data and we can manipulate and move things around using the struct to encapsulate things. In terms of grouping methods or functions with a struct, we can do this organizationally, but we will not be able to do it in terms of the tools of the language quite so elegantly as we can in C++. So let's begin. I'm going to, as a demonstration, create a simple program that enables the user to put in some information about one or more dogs, and that the information will then be stored in these objects, these structs, which we will create, and we'll call the struct we will create a dog. So to begin with, I will show you that I've already created a few supporting files here to begin with. One of them being a dog.h file. So the same way that we declare our classes in .h files, it's a good practice to declare our structs in .h files as well. So open up this. Oh, it looks like I already have this running, so I'll just foreground this. There we go. And we'll go to, oh, this is where I want to be, dog.h. All right. Okay, so just as with a class, we'll create a struct by using first the keyword. So instead of saying class, we'll say struct, and then we give the name of the struct that we'd like to create, opening and closing curly braces around the data items we're going to put inside of it, and then we can populate this thing. So I'm going to make it possible to store a name as a C string, and I'm going to use 21 chars or chars in this C string so that I can store a name up to 20 characters plus the null character. Alright, I'm also going to store as a float the age, and also as a float, if I can type, the weight of a dog. And that's that. So here we have declared a struct called dog. Now, .h files can be included in multiple source files, and it's important that they not actually be read in by the compiler more than once, because then we'd be trying to declare a struct called dog multiple times. So since we don't want to have to be very careful about the ordering of how our files are being compiled and so forth, we do want to be able to just say include dog.h wherever we know we're going to use dog, but we need to make sure that the compiler reads it and essentially copies that code into our program at least one time, but only one time. So we will do this by using some compiler directives. So if we put pound if ndef, that stands for if not defined, and then provide the name of some identifier, that some macro or variable that could be defined, like this. We will call this dog_h. Then what will happen is the first time that the compiler reads through this, or the preprocessor specifically reads through this, it will check to see if dog_h has been defined as anything. And when it sees that it hasn't, then it will continue to read through the rest of this, doing what it sees. Okay, now if dog_h has been defined, then it'll skip over everything until it sees this pound endif. Okay. Now, as it is, this code would still make it possible for us to effectively be trying to define the struct dog multiple times if we're including dog.h in multiple source files. So we need to also add actually the pound define of dog underscore h. Okay, so now the first time that this file is read by the preprocessor, it will see dog underscore h has not been defined. It will define it, and then we'll proceed to declare this struct and finally hit the end of our file, which also happens to have this end if at the end of it. Okay, so the first time that'll happen. The second time, or third, or however many times this is included in different places in our code, this if not def macro will be read. We'll see, the compiler will see that dog underscore h has been defined, and it will skip it, and that'll keep us from trying to declare it more than once. Okay, so I'm going to go ahead and save that, and I'm going to switch now. If I can get my shortcuts right, I'm going to switch to this main.c file. So my intentions with this program at this point are just to demonstrate then how to utilize this struct we've created. So I need to include dog.h so that, as this file is compiled, by the time I try using this struct, it has been declared. And I'm just going to do what we would normally do in C++. I'm going to name the type and give an identifier. And we would hope then that this would create a dog. I'm going to save this, and we'll see if that actually works. I have previously created a make file for this program, and so I'll just type make. You'll notice we get this error telling us that we have to use the struct keyword in order to refer to the type dog. Why is this? Well, I can't go into great detail, but in summary, it has to do with something kind of like the namespaces in C++. And so you could think of there being a namespace where structs are declared, kind of like how we have namespaces like std, or the standard namespace in C++. And in order to use things there, we have to specify that namespace. And so when we're wanting to use a struct in C, normally, let's see here, okay, we need to add this keyword struct. Doing so causes the compiler to know, oh, you're trying to use a struct, and it looks, you can think of it as looking in the appropriate namespace to find dog. Okay, now, as you can imagine, that can become tedious to always have to type this keyword struct. So, first let's show that this actually works. And we'll see that we no longer have an error. We're getting warned that we're creating a variable we don't use, but we'll take care of that in a moment. So this did the trick, but again, it's rather verbose. We don't want to have to type struct every time. The same way that we don't want to have to type, it's painful to have to type namespaces all the time in C++. So in C++, the solution to that is we can use the using statement and specify the namespace that we plan to be using quite a bit. We can do something kind of similar in this case. So, oh, pardon me. If I go back to dog.h, instead of simply declaring the struct dog and all of the rest of this, I can use what's called a typedef. And what the typedef is going to do is it's now going to define a type within what you might think of as the global namespace. And that's the same namespace that my functions and the other stuff I'm working with in my C program reside. And so doing this allows me then to essentially create a shortcut, you might think of it as, or a macro for this data type. Now, pardon me, I keep hitting the wrong keys and getting this beep from the computer. I apologize. So we can typedef this struct dog as something. We can give it a name that we want to define this type as. And in this case, a lot of times you'll see people just use the same name that they were using for the struct, but they'll capitalize it. So we could have this type dog. And now if I wanted to create a dog of this type struct dog, I could use this dog with a capital D, and I wouldn't have to type struct. Now, that works, but the reality is I can actually just use the exact same identifier. And the reason, again, has to do with this notion of kind of namespaces. So this struct dog lives in a different namespace than this typedef I'm creating that I'm calling dog itself. Okay, so it's really kind of strange. It's the same identifier, but they do kind of exist in different domains, so they don't collide with each other. If that's somewhat confusing, just remember that if you create a struct in this way, you don't have to type struct in front of the name of the struct every time you want to use it. You can simply type, in this case, dog. So let's go ahead and we'll save this. And I'm going to go back to main. And just to prove the point, we'll delete the word struct. And we'll try to build this. We see that we don't have the error anymore, just the warning. Okay, now how do we actually put data? Pardon me again. How do we actually put data in this object that we have created? So we do it the same way that we would in C. So we name the variable that we're trying to work with, and then we need to use the dot operator to specify the specific piece we want to work with. So I can say name. Okay, and then I can put some value in this name. We'll call it Buster. Okay, now this demonstrates one of the differences between a string and a C string. Okay, now you'll notice I'm trying to simply assign this string literal Buster to the variable name. And C doesn't quite know what to do with that. Now if I was working with a string in C++, it would just shove it right in there and we'd be good to go. We can't do that in this case, and so we need some other mechanism that will make this easier to do. So let's demonstrate that right now. What I want to show you is a function called, first let's go to c++.com. There's this function called string copy. And what that string copy does is it copies then a string from a source to a destination. So we want to make sure we get the order here correctly. Okay, so we'll need to also include here in c++.com they refer to C string, which is the library we would include in a C++ program. But for our purposes, we'll just need to include string.h. So let's go back and insert mode, and we'll include string.h. Now we have some functions that are used for manipulating strings. So I'll use string copy. And then remember, it was destination followed by source. Make sure I have that right. Yes, destination followed by source. So the destination in this case will be a dog.name. That's the string or the location of the string I'd like to copy into. And then I can put a string literal here. So I can say Buster. Okay. Then just to show that it has worked, let's try and print this thing out. Just the name portion of it. By similarly providing a dog.name as the argument to this printf statement. So make this. Now you'll notice that we're not getting an error. We are getting a warning here. That's because I'm using printf and it appears that I failed to, let's get rid of that warning. Yes, I failed to include standard io.h, so we'll just fix that. And we'll make again, and then we'll just try to run this. Yes, it is sort dogs, and here we see Buster. So we're making progress. So this has shown how we can create then a struct, we can declare one, And then here we have actually put a piece of data into it. And we've also demonstrated now how we can move strings around, copy strings around inside of C. If I wanted to set, I'll show this before I end here, the other fields, I can do so in a similar way. We had age, and I can set this to whatever I feel like. It's a very old dog, isn't it? 34.5 years. We'll pretend those are dog years. And a weight, we'll just make something up. We'll say it's 15 pounds. Okay, and then if we wanted, we could print those things out as well. For now, we'll just compile it to confirm that indeed we've obeyed the rules of the language. All right, so those are some of the basics of working with a struct. In a future video, we'll look closer at how we can create, for instance, an array of structs and get input into and read input out of them in that situation. Until then, I'll talk to you later.